my screen visible?
Yes, sir.
Okay, so I'm ready. So shall we start?
Yes, sir.
Okay, so you might have seen already that there are several OCR systems like optical character recognition systems, which the purpose is given an image, the software must identify and recognize what kind of text it is. Okay, there are many softwares are available in I think in this Google Play stores. Okay, so for English, have you tried these kinds of software for cursive text in English, or have you tried, and do you know any software for Indic script understanding? Yeah, any one of you, do you know? Have you checked some these kinds of softwares for this kind of scripts? Okay, this manuscripts, you just take a photo of this kinds of image, and then you apply those softwares. Will it work? So there's the challenge of handwriting recognitions. There might be several softwares which are developed for English handwritten character recognitions. Okay, so you know that MNIST dataset, digit datasets, which is very popular for machine learning. So anyone wants to develop any features or deep learning architectures, they need to test, okay, on this MNIST dataset, that okay, what is the accuracy. So have you tried with this handwritten Indic characters? So that's the objective of this work. The agenda is, I'll first discuss what is the challenge of this Indian text recognitions. Then I will discuss one framework for Indic handwritten recognitions. Indians, when I say this Indic, so it's mostly this North Indian scripts like Bengali and Hindi, where we have this headline. And then I will discuss one work on deep learning. So how we can use this deep learning for Indian scripts recognitions. Okay, so in that, as I was saying, these OCR systems are available and there are lots of softwares are there, but most of these softwares are used for simple single character recognitions or printed text recognitions. Like printed text means when you have image is very simple. Okay, so it's like computer generated scripts or newspaper kind of image where there is no cursive handwritten cursive text. So it is like an image, and then if you scan it or take a photo and then you use that software, then this will translate that image, okay, to an editable text. Means you see that this image is converted to an text file. Okay, so where those text information, whatever is there, this will be mentioned. So what is the benefit? Benefit is that you can do searching. So in that image, you cannot search some informations like communications or whatever mentioned it is mentioned, okay, in that image. But if it is converted, it is translated to an editable text, then you can do searching. That is the objective. And there are many other purpose also for visually impaired peoples. It is possible, or if you want to do some, for example, automations, for example, postal automations or banking automations. Okay, so these systems are very useful. So when we, if you see this history, so this for English scripts, this OCR systems came in 1950s. For Arabic OCRs came in 1970s, and nowadays there are many softwares for Chinese, Japanese, and this European languages. The main challenge is for cursive text. When we have text, okay, is written in cursive nature, so it is difficult to convert these kinds of text into an editable text, and the accuracy is not that high. So there are three kinds of handwriting acquisitions. So when I talk about this handwritten text, there are three kinds of medium acquisitions. One is offline. Offline means when what I say that you have already written something and that page is scanned and we want to know what information is there or what text is there in that image. These are offline process, means already this text are written in the page. Online is second. Online, this is uh, available when we use some, for example, this S pen or the stylus, okay, in a tablet. Okay, so we use this pen movements to write the text characters, and those movements are recorded. So for example, if I say that it is IIT, so if I make I and then some dot, so this every movement, so how I'm starting from top to bottom, okay, this direction, then there is a dot. So this all these movements, so if I just make a move, okay, so all these trajectories of this pen up position, pen down position, this will be available. So this information is useful for recognizing. So these are online. These are also some many companies are doing. Okay, so for example, like you might have seen in this e-commerce websites. Okay, so if you order some products and then they used to come and then they take some signatures 2 years back. Okay, so means those informations are available. And then there is another kind of acquisition process these days people are working. This is without pen and paper, means it is just in front of camera and people are using their finger for writing the text. Okay, and then camera will understand what kind of text it is written. Okay, that is ear writing. This is more challenging than this of online. But offline is, of course, it's very difficult because you will see that uh, offline there are several problems, issues. So what are the issues? So what you see in this, for example, data sets, so mostly come with the simple characters like MNIST data sets. You see this 10 digits coming with this numbers, letters, and then you have to recognize these full letters as a one uh, character. But these do not come in real life. In real life, you will not see that whether these characters are coming one after another. In real life, you will see mostly this full word image or a full page image. Like, for example, you have a text word and we want to recognize this. What is this? What is the text of this word. Okay, what are the characters in this word? So it is more challenging than the previous one, because here you need to know that what are the segmentation. Means if I just here this all these objects are segmented. Here these are not segmented. F is segmented, but O is and R, this is not segmented. If I want to segment these characters O and R separately, this is not easy, because I need to know, because human beings know that this is O and this part is R. So as we know that this is O, so we can segment. So we need to know that, we need to know before that it is O. That means recognition is required before segmentation. And recognition is for a computer, recognition is required for segmentation, and for segmentation, recognition is required. So this is like a chicken and egg problem. So you require segmentations. Means you have two characters O are together, you need to segment and then recognize, or you need to, for segmentation you need recognition and then segmentation. So that's actually a challenge. And then if we go to more complex, we have now these different words. And then if we want to recognize this, if we want to understand this full document, what information is there? Okay, that's more challenging, because you have many words and some of these words can be name. Like for example, it can be my name like Partho, and this name may not be there in the dictionary or lexicon. These words may be there in the lexicon, but this may not be there in the lexicon. So some words may not be there in the dictionary, and machine has to recognize, understand which words are names and which are not names. Okay, it is challenging. Now if I go to this second level, these are all in English. Okay, so where in English you have only 10 digits, and if I consider this alphabets, uppercase, lowercase, 26 plus 26, 52, and some punctuations, total it can be 70 characters. Okay, in Hindi, if we just consider this one of these Indian scripts, you have lots of characters. Okay, and here the number of classes are more. It is not 10. There are huge more number of character classes. And then it can be the same issues that you have word level. It can be in a character level, simple character level. It may be in a word level where you have a full headline which is actually connected to all the characters. So how you will tell the computer that where is the separation of each characters? Then the third level is you have a full image of Indic script text, and then text will be there, and as we use bilingual or trilingual, then in a same page there can be text of 2 or 3 different languages. So for example, if I am from Bengal, so I speak Bengali. So if I want to write a Bengali letter, sometimes I may use some English. So if computer needs to understand, decode this, it requires English and Bengali and Hindi sometimes. All these 3 character classes knowledge. So that means the complexity is more and more higher. So the recognition, if you see that people starts with this when they are moving to handwriting recognitions, and people are developing lots of systems, but though it is a very old problem, still we do not get good accuracy for this handwritten text recognitions, cursive text recognition. Why? Because the variation is huge. For me, if I write, okay, one words like cinema, if I write 10 times, uh, each of this will be different. Okay, they will not be same always. For me only, I can write different ways of this word. So now you can imagine if there are 100 people or 1,000 people, they write these kinds of text. So the variations is huge. And as I told you, this segmentations of characters is like a chicken and egg problem. So it requires segmentation, and segmentation requires recognition. So what people used to do for understanding or recognizing this English text or any kind of handwritten text. So there are lots of work like segmentation based work, and then you have simple shape based model. Okay, like they consider that full word is a object and word, and then they want to recognize these kinds of object. But these days most common approach is segmentation free, where you have a word and then we use a sliding slide. Okay, so like a window will be there which will give me the features, okay, from that part of that image, and then that window will move from left to right, and in each region I will extract that features. So those features could be, for example, shift, scale invariant features, transform, surf, hog. There are many kinds of features people used to develop. Okay, so in each window those features are extracted, and recognitions will be done with a Bayesian approach. Okay, so for example, we want to have these kinds of features, like if you have x1 to x10, 10 slides if you have, then what we want to do x1 to x10, this the features. Okay, so in each window there will be 128 dimension maybe, and given this sequence of features, I want to recognize the word. The word will be one of the word from the dictionary. Okay, I am having a list of words. It can be 1,000 words or it can be 2,000 words. So which word is having most probable of having these features, sequence of features? So note that these recognitions are done in a temporal domain. These are not in simple shape-based feature extraction, because this text can be of 2 feature length or it can be 20 feature length. For example, if I write a word like so, okay, it is a 2-letter word. There can be a word like statement. So this word is of 10 letters or 9 letters. Okay, so these features here, the sliding window may be moving for 3 times. Here it can move 20 times. So this is a temporal domain. So we need to use this feature extractions, okay, in a temporal domain, and then we need to recognize. And then if we apply this in Bayesian framework, that probability of words given this feature sequence, so it will be a conditional probability that we want to do it given any word. Okay, so what is the probability of this features? So we had earlier this hidden Markov model, which was very popular for handwriting recognition. Then we had this recurrent neural network, BLSTM, okay, and all these latest technologies for handwriting recognitions. And these are all used for temporal domain. Okay, that's why, as I said, this handwritten recognition, words recognition, is a time domain object recognitions. So that's why this HMM, RNN, BLSTM, these are coming. You cannot use this SVM or neural network for recognition of words. And then if you want to go for full document recognitions, so you would require this language modeling, okay, that whether what sequence is correct or not. It is similar to the speech recognition domain. So whether this after 4 words, the 5th word is correct or not. Okay. So that's more or less this framework for handwriting recognitions. And people used to develop lots of systems for Indian Latin text recognition, Chinese, Japanese, all. Now, if you consider this Indian handwriting recognitions in Indian scripts, okay, Indian scripts challenges, if you have, for example, a word, a letter like, let me show you one very, yeah. So let me show you one word that, for example, this letter, hey, okay, no, say, this word, okay, say, sub say, okay, where you, what you see there, here you have this character sir, sir, and then you have a modifier. Okay, so if you want to recognize this using this HMM or this BLSTM framework, then the number of characters will be huge, because here you see that in this part you have a character called sir, and then this part it is not sir, it is say. Okay, because of this modifier, the character class is different. So because of this different combination in Indian scripts, the number of classes is huge. It can go 400 to 500, because you have these half characters, okay, vowels and consonants, there are different combinations. So though the characters are same, because of some modifiers, the number of characters will be huge. So if we want to go for recognitions of that this is a character, this is a different character, then the recognition will be around 40%. Okay, so if you just say that, okay, these are all are 400 different character class, 400, 500 character class. So what we are planning, what we did, that instead of recognizing this full text, okay, with this different character class, we thought of reducing this number of character class. How? So we said that, okay, so instead of this full text, I just remove this upper part. I do not consider. And then lower part also I will not consider. Now I recognize this middle zone. In middle zone, this is called this busy zone or middle zone. And this upper part and lower part, these are the different zone, okay, of this word. And in this middle zone, mostly those characters will remain same. Okay, for example, this, you see this, hey, if you just do not consider this upper modifier or lower modifier, this will be her only. So the same character class will remain same. So now we can reduce this number of classes by huge. It can be 60 to 70. Okay, by removing this upper part and lower parts. I'll not go into details of this pre-processing parts. So, but I'm just giving you the idea that what was the um, idea for improving this Indian handwriting recognitions from 40%. So if you do for 400 character class, it will be go for only 40%. So what was the idea? That you given an image, so we do some pre-processing, remove this upper parts, lower parts, and in this middle zone, we use the sliding window. Okay, so we will have a sliding window. So in each slides, you will extract the features, and then those features can be fit into this HMM or LSTM framework, and this will recognize this middle zone. Okay, so what are the characters are there? And after that, those characters will be combined. Okay, this asking if we know these characters, and then we'll combine this upper lower parts. Okay, that we know that, okay, in the upper part also what are the modifiers are there, because this will be a single shape. There will be no temporal shift, because this is a single character. There will be some characters, small symbols. Okay, these are all mostly segmented. So when these are segmented, we do not need time series analysis. we can do for simple SVM or neural net based classifiers. And then we know that, okay, this upper lower part, you have this some dots, and this middle part, this is bar, okay, and then upper parts you have some modifiers, and then we just make some Lego. Okay, so Lego pieces, like you have some recognition of this middle zone, upper zone recognitions, and lower zone recognition, and we just combine. Okay, so which are the possible combination which will give me the best word in the dictionary. So using this approach, we see that it goes to a very good system. We can develop a system uh, with 1000 words in a dictionary. The accuracy can go to 86%. If the lexicon size is 5000, the accuracy will go to 71%. Okay, but still from 40% to 71%, it's a huge jump. So you see that given a sentence, we can, if we apply that system, then it will convert this sentence into this as editable text. Okay, similarly in Bengali or Hindi or if any script which is having this headline. So the objective is what we are doing. So we remove this upper part and lower parts, and then middle zones we just do using this classifications, and we reduce the number of character classes. Okay, so if we do not use the zone segmentation, it will go to 42%, and we are going to using this zone segmentation, the accuracy is 71%. Now, the next challenge is, if you see this in Indian scripts, how many data sets you find? If you want to develop a Indian scripts, like for example, Odia text recognitions or Tamil text recognitions, do you find any publicly available data sets? Mostly no. Okay, because this annotation of this text is very difficult. It's challenging. In English, Japanese, or other scripts, these are also challenging, but they have developed and they share. In India, we do not have this much, this kinds of corpus, okay, for this machine learning purpose. So we do not have data sets on Indian scripts. And then if we want to develop a deep learning framework on these kinds of Indian scripts, then how it will be easy, how it's possible. So we require some annotations. Okay, so when I say that low resource scripts means the data is not that available. Okay, so data set for that script is not available, and you have some kinds of annotation, some few words, as for example 1000, 10,000, 2000, but you do not have a lot of data. So if you have only this few data, how can you use this deep learning for Indian script recognitions, and where the number of classes are huge? So we require synthetic data generations, okay, or data augmentations. So this can be done in two levels. One is image level, another is feature level. If I just talk in a layman words, that how we can generate the words, okay, text similar to your objects. Okay, so in objects you see that objects, I can take some parts or I can make some deformations, okay, of these objects, then we can increase the data sets. Similarly, in text also I can deform, okay, and these deformations will provide me lots of data. How? For example, we can use this e-newspaper kind of data documents, okay, e-newspaper or PDF. Okay, so you have some text, you have for example, you have a PDF file, and this PDF file you have some text words, okay, and you see this image, this words, you can crop that image, and for that image you have already this ASCII text. Because it's a PDF, you can know that what is the text, and if you zoom it, you know that what is the Hindi or Bengali shape of that image. So you have that shape, along with you have the annotations labels. Now can we use this shape and this annotations to increase the data set, means to have the synthetic data? What we are doing, so given this label, okay, so we have this label, we have a label, and we have the shape. So for every word we have the label and the shape. So what we are doing, so we can for this shape we are changing it into using these deformations. Like for example, these deformations can be in a stroke level, or it can be in a word level. Stroke level means for each stroke, if I am having some strokes like this, okay, so this is a stroke. So this stroke can be here, this stroke I can change it a little, and then I can move these strokes like dancing, okay, and here and there, and I can increase the data. In labels also I can use, for example, if this label, whatever label you have, okay, using this label I can use a different font, and then my shapes will be different, and then accordingly I will modify with these vectorizations or deformations, and I will have that's also, it is one of the approach. Now let us see this how deep learning can help us. So deep learning as just a simple framework, that how deep learning will help in this uh, recognizing the words. So it's a simple framework. Okay, so now it may be old. In 2017, we had this work on this end-to-end trainable neural network for image-based sequence recognitions and application to scene test recognition. What they were doing, you have this image, okay, any image like so statement that I said, and it is the input, and then after that there is a set of convolution layers, which is convolution, max pooling, up to this, okay, a set of convolution, max pooling, and then we have this map features. From these features we use extract the features to a sequence, okay, these features we convert into a sequence levels. Okay, so the sequence, like these are the column, okay, so these are the all these columns are extracted. So all from this columns feature sequence I can apply a RNN, LSTM, this kinds of frame. So this is a CNN based features, and here the system is RNN. Okay, so we have this end-to-end system for this from an input image to this recognitions. And then finally we will have used this CTC layer or transcription